Once again, good morning. In the last video, we were discussing about data integrity, and we stopped at data integrity checks. So, what data integrity checks means is actually a mechanism, or rather a way to measure the consistency of a collection of data, a file or picture or a record. The integrity check performs a process called the hash function to take a snapshot of data at an instant in time. So this mechanism is very, very important in so many ways that we ensure data integrity. It helps us it is used by different protocols like transmission control protocol, in OSI layer, is actually using this integrity check to help to and check the validity of the information it receives from another end. All right, so now okay, availability, which is the last dimension, in the 3 dimensions we are speaking about. Now, what is data availability? Data availability is the principle used to describe the need to maintain availability of information and services at all times. So what is expected is that these resources, services, and information should be accessible by the legitimate users all the time, all right? And then in so many cases, cyber attacks and system failures can prevent access to information systems and services. Hence, the reason why it is important for us as cybersecurity specialists or students to be able to, safeguard that from happening, protect that from happening. So some of the methods used to ensure availability include system redundancy. It means, what do you mean by system redundancy? Redundancy, it means if you have a network and then you only have one edge router, then your network doesn't provide redundancy. There should be an alternative, edge router with an alternative internet service provider, in a way that if one router is down, then other one should work so that you will not experience downtime. Okay, you have router A. Router A is from Airtel. Then router B is from MTN. MTN is providing you internet as a backup, so you sign what we call an MOU with them that you are going to be using their services, so you need to be having internet when you need it. The same thing with Airtel. You have an agreement with them. You sign an MOU, memorandum of understanding, or memorandum of agreement, or whatever you call it. So through that, you'll be able to provide what you call redundancy. System backups, it is by creating daily backups and then ensuring that backups is accessible within 10 minutes. What do you mean by that? Some organizations, or be it private or government, they actually outsource all these services. So in a case whereby this information, in a case whereby organization that you're working with outsource these IT services to a third-party company. So what do you think will happen? They always recommend that a dedicated staff, 1 or 2 should actually be, should be available, in the organization. And that way you'll be able to, provide this 10-minute policy. You have your backup, you should be able to roll it back within 10 minutes. It shouldn't take longer, it shouldn't take forever, because the essence is to improve on your business continuity plan. Business continuity plan allows, state a lot of information on how some critical business operations should actually remain accessible and intact whenever uh, whenever that is required. All right, so that is some of the method. And then increased system resiliency. System should be as resilient as possible. Equipment maintenance, you should always maintain your equipment so that you, at a point in time, you will not know, maybe rat might have eaten the cable, or your hard disks actually shifted or something like that. Up-to-date operating systems and software. So you should always apply, maintain, and update your operating systems and the software. Plans in place to recover quickly from unforeseen disasters. There should be fantastic, disaster recovery plans in place that is tested and is actually found working. High availability systems typically include 3 design principles. Like when we say high availability, we are referring to, critical infrastructure and system that need to be available almost 24/7. So what are these design principles? We are to eliminate single point of failure. We are to eliminate single point of failure, meaning that if there is a particular point whereby when, let's say, for example, in the topology, if I cut a wire in a certain area, then there is going to be some certain places that will lose connection. That is not a good design. So we should eliminate single point of failure. And also this could be, an example of this could be in terms of redundancy that we just explained, in terms of redundancy that we explained. When we look at that, if you have one single edge router, then chances are one day you are going to, you will lose connectivity entirely. Your system is going to be offline. Provide for reliable crossover, okay? And then lastly, detect failures as they occur. So these 3 design principles are very, very important and are required to be implemented for high availability systems. Organization can ensure availability by implementing the following. So if you want to actually get high availability, you are advised to implement the following. So you as a cybersecurity specialist, you should know this very well. And this should actually be part of your daily activity and daily operations. Number 1 is equipment maintenance. You should maintain your equipment. Operating system and system update. You should update the operating system and update the software as well. Number 3 is test backups. You should test your backup and see how smooth it's going to be. The process of recovery or rolling over, how smooth it's going to be. Plan for disasters. You should always plan for an unforeseen disasters that might occur, which can lead to downtime. Implement new technologies. This allow you to use advanced technologies to implement certain changes. Monitor unusual activity through the login or logs, the system logs, so that you know what is happening, and that will help you, to a kind of know who are targeting your system. Lastly is test to verify availability. You are to run system testing to verify availability, to verify the availability of the system. So these 7 steps are quite. Yes, please. Yes, Ibrahim.
Confine this number 7, test to verify ability. Is there any process or method that used to test or verifying any system that are on?
Okay, to test or verify to verify availability is that when you are maybe in your in the organization's disaster recovery plan, they have this as part of the activity they want to carry out. So what this actually one thing that I'm thinking that we can actually do under this is to firstly, like when you design a network, right? When you design a network, you will run some testing on the network after releasing it, after launching that particular network. So after launching it, you test it. And then in a case whereby maybe you have an agreement with another organization, you might, for example, 2 banks in Nigeria, okay? Let me use that as an example. If you have, say, Zenith Bank and UBA, okay? So they might have an agreement that they have certain areas that they will compete on, but they will not compete on critical infrastructures, okay? So in that case, they will sign an agreement, if a disaster happen, some of their staff will go to the other bank's facility and use it to avoid long-term of recovery. So how do you mean? So to test to verify availability will means you are to test your infrastructures and ensure that the infrastructures are going to be available in a case whereby an unforeseen disaster occurred or happened. Okay, so this is actually what I can add to this point. Ibrahim, is it okay?
Yeah, it's clear.
All right.
But what has happened to this our police? I like his offline. What's his name?
Joseph, yes, quite sure. I have
But I saw his text reaction on what is happening.
Yeah, actually, we are very okay, and I don't know. All right, so now, state of data, as we have seen initially in the MyCube, in the cybersecurity MyCube, we have seen that we have 3 dimensions. Okay, we have the countermeasures, we have the information security, and then we have the security principles. So the information state is basically the state of data, which we are going to discuss in this particular section. So data at rest. Data at rest is actually stored data. Stored data refers to data at rest. Data that is stored in a storage is what we call as data at rest. So data at rest means that a type of storage device retains the data when no user or process is using it. All right? When no process or user is using that particular data, then the data, and also it is stored on a storage, then we can now say the data is at rest. A storage device can be logical on a computing device or centralized on the network. A number of options exist for storing data. So, pardon?
A storage device can be, is it local or logical?
It's local. It's local. A storage device can be local, that is on a computing device. Local, it means like the hard drive of your computer is local because it's inside your laptop, and you're storing the data inside that hard drive. Or centralized, that is on a network in a case of client server architecture. Okay, you have a central server and then all the systems that are client are connected to that server, so they access the information and the data when they need them. Number of options exist for storing the data, okay? Direct attached storage, that the acronym as DAS, is storage connected to a computer, like your flash drive or external hard drive are all examples of direct attached storage. This direct storage, attached storage, are also used as for storing data. So data could be addressed in this medium as well. Redundant array of independent disk, RAID. RAID means redundant array of independent disk, uses multiple hard drives array. So this RAID is actually a way of arranging hard drives. You know, you arrange hard drives and you stack them, you know, on the RAID. So in that way, the operating system sees them as a single disk. Okay. RAID provide improved performance and fault tolerance. So in a case one hard drive is faulty, you know, the system will actually not notice, because all the hard drives that are arranged or stacked, you know, in the RAID are considered to be one. So if one is faulty, then of course the rest should actually continue working, and that is a means of providing redundancy, or rather fault tolerance. Network attached storage, NAS, is a network attached storage device. Is a storage device connected to a network that allows storage and retrieval of data from a centralized location by authorized network users. This network attached storage, as I explained earlier, we in a server client, in a client server architecture, we have a central server where all the information is stored, all the data is stored on that server. So in that case, we have this network attached storage. The NAS device are flexible and scalable, meaning that administrators can increase the capacity as needed. So in the RAID, because RAID can contain multiple hard drives, so if you want to add the capacity of the server, you just have to go and buy new hard drive and of course attach it, you know, inside the RAID to increase the capacity. Additionally, we have a storage area network. A storage area network architecture is a network-based storage system. SAN, that is storage area network system, connect to the network using high-speed interfaces. This is a form of NAS, is a form of network attached storage, but the peculiarity of SAN is that it's using high-speed interfaces, allowing improved performance and ability to connect multiple servers to a centralized disk storage repository. Now, so this all is to allow us to understand the technology behind ensuring proper storage system, you know, in a computing environment. Data in transit. Data in transit, this is data transmission. The data transmission involves sending information from one device to another. There are numerous methods to transmit information between devices, including SneakerNet. What do you mean by SneakerNet? This uses removable media to physically move data from one computer to another. So if you bring your flash, Ibrahim, you bring your flash to me and I copy a file, you know, I'm transmitting data using a method called what? SneakerNet. All right. Wired networks uses cables to transmit data. You can also use data cable through what we call peer-to-peer. You bring your system, I will just bring my own as well, use data cable to transmit data. That is wired network. Wireless network uses the airwaves to transmit data. So we can also communicate wirelessly to share the information using what we call airwaves. That these three are different ways of transmitting data, and they ensure data in transit. Protection of transmitted data is one of the most challenging jobs of a cybersecurity professional, you know, because, you know, this data, you know, is in between two people. system A and a system B, a sender and receiver. So protecting it at that intermediary level is quite task. So protecting data confidentiality is quite very important. In that case, as cyber criminals can capture, save, and steal the data in transit. Protecting data integrity, cyber criminals can intercept and alter data in transit. And lastly, protecting data availability, cyber criminals can use rogue or unauthorized devices to interrupt data availability. So these these three techniques are quite important, and they are very, very important, and they are very, very handy. Now, lastly, data in process. The transfer of data during initial input modification, computation, or output refers to data during initial input. In process, I mean, that means you are just making entry, you are just registering, you are just adding your information on that platform. Modification, or you are just altering the data. Computation, like a certain computational processes is being carried out, or the data is just being outputted. So in these 4 different scenarios, we can define to say that data is in process. Protection of data integrity starts with initial input of data. So as we said, if you want to protect or ensure optimum data integrity, you have to ensure that you collected the right data. By ensuring data validation, you run data validation checks. So when you run data validation checks, that allow you, to ensure optimum data integrity. Organization use several methods to collect data, such as manual data entry, scanning forms, file upload, and data collected from sensors. These are different ways that organizations collect data. Each of these methods pose potential threat to data integrity. Each of the 4 mentioned, it poses potential threat. It rather create potential threat to data integrity. And data modification refers to any changes to the original data, such as users manually modifying data, programs processing and changing data, and the equipment failing results in data modification. Now, that is data modification essence. Processes like encoding / decoding, compression, decompression, encryption and decryption, and decryption are all examples of data modifications. Malicious code also result in data corruption. So what we mean, as we have seen, if you are encoding a data, it means that you are actually the encoding means you are changing the form in which you are going to send the data, right? Then decoding is like retransforming the data back to its initial format so that the receiver could actually make sense of it. Compression is when you compress the data in order to reduce the weight or kind of for any purpose. Decompression is when you retransform it back. It's when you retransform it back for the sake of understanding and for the sake of access. Lastly, encryption and decryption are the terms that I explained earlier before. So this is data in process. So remember, data could be in different states. Data could be at rest. Data could be in transit, and then of course data in process. So yes, is that clear, Ibrahim? All right. So I think for the sake of clarity,